In this video, I'm going to be showing you how to see if the infinite series from x equals 1 to infinity of the function 1 over 2 square root x converges or diverges. So the first thing that we're going to do is we're going to draw a sketch of this function here. So we know, because this is going to be a reciprocal curve, it's going to be something along the lines of this shape. That's a bit inaccurate, but it's going to be something along the lines of that. Then we're going to call this point here 1, 2, 3, 4, 5, etc. Now, if we was what the infinite sum is saying, so from x equals 1 to infinity 1 over 2 root x, this is going to be the same as saying 1 over 2 times the square root of 1 when x is equal to 1 plus 1 over 2 square root 2 when x is equal to 2 plus 1 over 2 square root 3 when x is equal to 3, and so on up until 1 over 2 times square root of x. So what this basically is just a bunch of rectangles really. So when x is equal to 1, it's going to go up to its output of this function, and then we're going to go over to 2, and then it's going to be this area. So that's what this represents. Then plus 1 over 2 square root 2, that's just going to be this area here added to it. Then when it's 3, it's going to add this area. When it's 4, it's going to be this area. So we can see, so let's note that the summation from x equals 1 to infinity of 1 over 2 square root x is gonna go above the line of the function. So this is the line of the function here, 1 over 2 square root x. So we know also that the exact area under this curve, so exact area under curve, is going to be equal to the integral of this function. So the integral with the same bounds, so from 1 to infinity, so it's going to be an improper integral of 1 over 2 root x dx. So what this is saying, what we can conclude from this, is that as these rectangles get infinitely small, then the area is going to become increasingly more accurate up until when they're infinitesimally small, which is when our integral comes in. So we can see that the summation is going to come above the integral. So you can see these little bits here sticking up past the curve. So we can say if the integral from 1 to infinity of 1 over 2 to the x dx diverges, we can also conclude that the summation from x equals 1 to infinity of 1 over 2 root x is also going to diverge. And this is because this here is going to be greater than this. So if this goes up to infinity, obviously this is going to go up to infinity as well. So now we're just left with an integral to solve. So the integral of 1 to infinity of 1 over 2 root x dx, obviously we can factor our half. So it's going to be equal to 1/2 times the integral from 1 to infinity of 1 over square root x dx. We can just write this as x to the negative half power, because obviously square root is just a half power. So I'm going to note this actually. So note square root of x is just equal to x to the half power. I'm also going to say 1 over a. A is just nothing to do with this. I'm just using it just to explain. 1 over a is going to be the same as a to the negative 1. So if you put these together, 1 over square root of x is going to be equal to x to the half power. And then on the outside of the bracket, we're going to have negative 1. Multiplying them together, we're going to get x to the negative half power. So I'm just going to rewrite that there. So we're left with the integral, half of the integral from 1 to infinity of x to the negative half power dx. And then we can just solve this simply with the power rule. So we can add. So I'm gonna write this again actually. So we're gonna get 1 over 2 And then opening the bracket for the output of the integral, we're going to get x to the positive 1/2, because we add 1 to negative 1/2, divided by the new power, which is 1/2. Obviously, we can bring the 2 to the top, so we just get half times the times 2x to the half power. Obviously, this half times 2 is going to cancel out, so we're just left with x to the 1/2, which is just going to be the square root of x. So now we need to put our bounds in. So we can say that the indefinite integral of 1/2 root x dx is going to be equal to square root of x. So then when we put our bounds in from 1 to infinity, we need to solve this from 1 to infinity. So obviously, if we put our upper bound in first, square root of infinity, that's just still going to be infinity. Take away the square root of 0, obviously the square root of 0 is 0. So we're just going to get infinity take away 0, which is infinity. Therefore, we can say that the integral from 1 to infinity of 1/2 root x dx diverges. And knowing that, we can go back to our point here. So we're also going to say that, therefore, the summation from x equals 1 to infinity of 1/2 square root x is gonna diverge.